Good afternoon, everybody, and welcome to this session. We're going to be talking about the Meadow ecosystem. A small amount of housekeeping before we get into the main presentation. First of all, can everybody bear in mind the code of conduct? I mean, we're not live in person at the moment, but there are discussions going on the Discord server, so please be considerate to others and consider their views. Normally, we've got a number of sponsors, and even though we're online and there's little cost to this event, the sponsors have still agreed to donate towards the event, and we're going to be putting that money towards the National Museum of Computing. And our sponsors today, we have Sage, Landmark, NDC, and Black Marble. They've all either put time into getting this event live for you, or they're donating some towards the NMOC. There is also a golden ticket to NDC, and that will be raffled at the end of the day. Ensure that you're registered with Eventbrite, because that's the only way you can be entered into the raffle. And we're also tweeting, so you can follow us at Developer Day on Twitter, and you can use the hashtag DDD2021 if you have anything to say about the event. Okay, so let's move on to talk about Meadow. So my name is Mark Stevens. I am actually involved in the development of the firmware for Meadow. Previously, I have been a software engineer, project manager, and an operations manager. And about 3.5 years ago, I started working on the firmware with Wilderness Labs. And I've been writing software and tinkering with hardware since the 1970s. And you can follow me on Twitter, or if you want to know what I'm doing, I'm at Nevin UK. So today, we're going to start off having a look at the embedded and IoT environment as it stands today. Then we'll move on to have a look at the Meadow ecosystem, so the hardware, the operating system, the development environments that are used to actually write software for the boards, have a quick look at the driver library that we've got available. And then we're going to venture into the brave world of demonstrations. So it's either going to be a few demonstrations on how to use the product or 20 minutes of me trying to figure out what's going wrong. I'm hoping it's the former, not the latter. And we'll end the presentation with a look at what Meadow has in store for it in the future. So let's start by having a look at the state of embedded development today. So we've seen compute over my lifetime. I've seen compute move through several phases. I started work on mainframes. I've used mini computers in the past. Most of my time has been working with desktop computing. And then around about the time the iPhone came out, mobile computing started to take off, and products like Xamarin really opened that up to everyone. And the next big thing is predicted to be the Internet of Things, or IoT. So if you look at the world around us at the moment, virtually everywhere you turn, you're going to be looking at an embedded device, and some of those things will be Internet enabled. So think about things like smart meters. If your electricity and gas is being reported to an energy company, they're probably using something called, I think it's the Zigbee network, and that will have an embedded microcontroller in it at the heart of it. Hive thermostats, the intelligent thermostats where you can actually change the temperature of your house from across the internet. Again, that's going to be an IoT device. And there are predicted to be about 75 billion devices going to be in the world around about 2025. Now, that's not that very far away. Even if we are generous and say December 2025, that's still only 4 years. And that would be 3 times the number of devices that we think are out there at the moment. So it's IoT's gaining in velocity. We're starting to see it in more and more places. It's going to be all around us very, very quickly. So when we develop for boards as they stand at the moment, we're traditionally writing in embedded C or assembly. The two images that you see at the side of the text, they are how our development environment, the Meadow development environment, has progressed. So that's the environment that I would use to develop on those boards. The whole idea is to give an easier way for end users, programmers, people like yourselves to actually use these boards if you want to. So my development rig, there's 4 USB ports there that allow me to talk to the boards. The aim is that if you want to develop for Meadow, you will only need 1 USB port. It's going to be a really easy and pleasant experience. Now, there are alternatives to C and assembly. MicroPython and CircuitPython are very common, particularly in boards from people like Adafruit. There's also the possibility of developing in Rust. That's taking hold. You can actually see more and more boards with ports of Rust onto the board, and Ada's also out there as well. The problem with some of these is that depending on the chip combination, the language that you're going to be using, there can be limited support for drivers, for sensors, for peripherals, and they're often really difficult to debug. I mean, if you just look at those environments, we're talking 2 different debug probes that are talking to the chips on the Meadow board. So the additional hardware that you you're required to have available to you to debug these boards makes it difficult and more complex to actually get involved in embedded development. And hopefully Meadow is going to make that a whole lot simpler. Now, .NET has been around for microcontrollers for quite a while. Microsoft originally started with the micro framework, NetMF. That was abandoned a while ago, but some people took it on as an open source product, and they created the Nano framework from micro framework, and that's starting to get a wider variety of processors, be available on a wider variety of processors, namely the STM32s and the ESP32 range of microcontrollers. The thing about Nano framework is Nano, as it suggests, it's small, so it's not you don't have the access to the full .NET libraries, and at the moment it's restricted to C#. Raspberry Pi, now that is, you can do full .NET development on the Raspberry Pi, but it's relatively power hungry when you compare it to a microcontroller. And that's where we think Meadow is going to step in. So we are full .NET 2.1 standard compliant at the moment. We are going to be working on .NET 6, and we're hoping that that will become available sometime next year. We have 2 microcontrollers on the board, the STM32 and the ESP32. So that gives you the ability to work in low power modes. So you can work in environments where solar or battery are your only means of power, where you don't have any mains power supply. The board has Bluetooth and Wi-Fi built in, and that's provided by the ESP32. And you can choose your language that you wish to develop. So we give access at the moment to C#, F#, and VB.NET. And we're looking at a cloud management being rolled out in the near future. So if you have a wide number of devices, you can manage the system updates, application updates, and you can do all that through the cloud. So that's where we're heading with that. So let's have a look at the hardware itself. At the moment, we have 2 boards available. The one on the top left is currently in production, and we have units available, and that is the Meadow F7 Micro. The board on the right is the core compute module, and that has the same facilities, if not a few more actually, of the F7 Micro. It has more GPIO. It also has the ability to connect to Ethernet, should you, as well as Wi-Fi. They are both low energy boards, so battery power is perfectly feasible. They're both surface mount boards as well. So surface mount means they're totally flat on the bottom, so you can use the same piece of hardware to do your development as well as you would use on your production boards. And the aim is for the core compute module to be available pretty soon, and it's at a low price of around about $30 per unit. So let's have a look at the features. So we're talking microcontrollers here, so we're looking at kilobytes and megabytes. We aren't looking at gigabytes of memory. So we've got a small amount of RAM internal to the chip itself. So that's the STM32F777, which is the main controller chip. Wi-Fi and Bluetooth is handled, as I've mentioned, by the ESP32. And we have 32 megabytes of external RAM, which is pretty beefy for a board of this sort of nature. And we have 64 megabytes of flash available. So that's flash storage space for your program, storage space for data, and so on. There's a combination of 25 GPIO pins. And as I've noted earlier, the F7V2 is a surface mount board. This is the second evolution of this board, and they're the ones that are currently in production. So you can use this in both production and development environments. So as I mentioned, we have 25 GPIOs, and you can use those all as digital GPIO pins should you wish. Or you can use them in combination, so you could have 6 analog pins. You could use the SPI bus for talking to peripherals, and that still leaves you 16 GPIO pins. So it's up to you what your application, depends upon your application needs. So next up, let's have a look at the operating system stack. So we have 2 microcontrollers. On the STM32, that's where your application would be running. And obviously you're using the .NET libraries, so you're going to have access to the system namespace and so on, all provided by the base class libraries. But there are also some Meadow libraries that are available to you should you wish to use them. And these allow you to do things like communicate with the hardware. So you could talk to those GPIO pins. You can take analog readings from various sensors. They all sit on top of Mono, and Mono's really running the .NET show. And underneath that, we have a real-time operating system, RTOS, called Nutex. So there's a platform abstraction layer that sits between Mono and Nutex, and that's a POSIX abstraction layer, and that allows us to talk to Nutex itself. The ESP32 is using FreeRTOS as its operating system, and that is providing services through to Nutex in the form of Wi-Fi. And also to the Meadow libraries, we provide access to things like Bluetooth configuration, which is provided by the system threads that are running on the ESP32. And between the 2 operating systems, we have an SPI, a serial peripheral interface hardware layer, which allows the 2 systems to talk. So that's how the systems are working. So you have your code running on the STM32, and the ESP32 is providing support services for you. So we've looked at how the stack is layered, but within the Meadow drivers themselves, we're providing a set of core features. So network being one of them. So the F7 micro that we have on sale at the moment, that is providing with a Wi-Fi connection. the core compute module that provides both Wi-Fi and Ethernet, and both of those have full SSL. And I think we're all pretty, I think we can all agree that SSL is pretty important when we're talking out to devices on the internet. We provide access to a BLE, Bluetooth Low Energy server, and again that's through the Meadow libraries, and we've simplified the whole BLE process, because BLE can be really difficult to get your head around and to actually get up and running. So that's all taken care of for you. There's persistent storage, and you can available using the flash chip, and you can do that in one of two ways. You can either use SQLite, and you can use the SQLite .NET libraries to store data in a SQL persistent file storage mechanism, or you can just use the basic file system that's there on the board. So you can write out text files, write out config files, etc. It's up to you how you want to actually deal with that. On top of that, we have something called a watchdog timer, and these are relatively important for systems that are going to be out there in the field, systems that are going to be running for a long time. They will actually keep an eye on the system, and if the timer thinks that your application has crashed or the board has crashed, it will automatically reset the board, so it will bring it back into a good state. So you can be pretty confident that your board can be left alone for long periods of time, and if necessary, will restart itself. And these are pretty common in the embedded world. So let's have a look at the different environments that are available to you. Development environments. So we have the ability, we can develop on the three major operating systems, Windows, Mac and Linux. VS Code is available on all of the operating systems, and we're currently supporting Visual Studio 2019. Again, on Mac and on Windows. Visual Studio 2022 extensions are currently in flight, so hopefully in the near future you should be able to use 2022 if you wish. On top of the development environments, there are two things that you really need to install. There's an extension for Visual Studio, and this allows you to talk directly to the board itself. And there's also a command line tool, and the command line tool is used to do things like operating system updates. And you can also use it to interrogate the board. So if you think, for troubleshooting to see if making sure all the files that you think are on the board should be there, making sure that the device has been updated correctly and so on. And as I've mentioned earlier, you can use whichever language you feel you are comfortable with. So if you're comfortable with C#, you can use C#, you can use F# or VB.NET. The debugging experience is fully integrated with Visual Studio, so you get the ability to set breakpoints just as you would do on desktop development or on web development. It should feel really comfortable if you're used to working in those environments. Visual Studio Code can also be used. I've used that in combination with the command line tool, and I think there's some work going on to actually make that a lot more seamless, so it feels just as it would do with Visual Studio. And if you really want to, you can use the mono command line debugger, but I think we're all pretty much agreed. Debugging with the IDE is the preferable way to go. So Meadow Foundation provides a comprehensive set of device drivers. So the device drivers allow you to talk to peripherals, things like motion sensors and so on. It's an open source library. If you feel that there's something missing from the library, then take a fork of the library, write, add to it, create a pull request. We're open to people contributing, and we do have several people who have contributed drivers already, and we're continuing to add drivers every week and every month. Each driver is normally provided with a sample application along with any data sheets regarding, say, the sensor that's being used. We try to make sure that the quality is consistent. If there's a design pattern that is favoured, then we try and make sure that every new driver that's submitted follows that design pattern. And as well as the drivers, we have documentation on the developer website. So each driver will have its own set of docs. There's more than 100 drivers. So they cover everything from displays, so things like LCDs, OLED displays, simple text displays. Today, if everything goes okay, we're going to be looking at a light sensor, a distance sensor, and a motor driver, and we're going to be pulling those out of the Meadow Foundation, and we'll see how that's done later on. The drivers are available usually as NuGet packages. So again, this should be using skills that, as a developer, used to working in web applications or desktop applications, these should be just reusing your existing skills. We also have a number of sample projects. These are available on Hackster, as well as through the developer and the GitHub repository for Meadow Foundation. So let's have a look at Meadow in action. So today I'm hopefully going to be doing 3 different demos. So we'll start up with the basic how do I get everything up and running, and I'm going to be using Visual Studio 2019 on the Mac. We'll do that in F#. We'll have a look at using a light sensor to work out how bright it is. And then hopefully we shall start to look at a buggy, a Mars rover, and we'll start looking at controlling motors and measuring distance. So the getting started is what we call a Blinky application. So in the embedded world, Blinky is the equivalent of Hello World. Basically, we're just going to look at flashing an LED on and off, or changing, in this case, we're going to look at changing the color of an LED. And we're going to do that in F#. The next project, we're going to use a light sensor. We're going to take light level readings, and we're going to have a go at sending those readings up to an Adafruit data logging service. And then the final demonstration is hopefully going to be the rover, which you can see at the top. We're going to have a look at driving the wheels on the rover, and then we're going to have a look at using the distance sensor, which is at the bottom, to take readings from the sensor and then try and put some sort of collision avoidance in place. So over to Visual Studio. So our first demonstration is just looking at getting started. So we're going to create a brand new project. And I've got the extensions installed already. I'm going to create a Meadow application. I'm going to do that in F#. I'm going to give it a name. Getting started. And I'm going to put that in my public directory. And we click create. Legal solution. Okay. So for those of you who are familiar with C#, hopefully this will look sorry about this. The demo gods are obviously not on my side today. I'm just going to kill Visual Studio and we'll see if we can coax it back into action.
I'll answer a couple of questions whilst you're doing that.
Yeah, sure.
So first one is, for the cloud management, is this going to be a Wilderness Labs cloud, or can we use tools in Azure AWS to manage them?
This will be a Meadow. This will be a Wilderness Labs cloud management, because we'll be taking care of things like device registration and so on.
Okay. Second one is, how low power can the system run? For example, on a battery, can we have ESP wake up the STM on a timer, so down to deep sleep and ultra power? I know this was something early betas couldn't do, but hasn't seen it announced.
No, this is something that will be coming prior to revision 1 of the system. The power management APIs are currently being designed. So the intention is that the whole system can go to sleep and be woken as and when required. Say if you're doing something like a weather monitoring, where you only want to take a reading every 15 minutes, we'll be looking at getting that sort of feature. That will, yeah, we'll be looking at getting that going.
Okay, that's it.
Okay. Still not playing ball. Okay. Hopefully we'll have better luck this time. Yay. Okay. So some F# code. So as I mentioned earlier, you are required to add an extension into Visual Studio, and this is available in the gallery. So if you just search for Meadow, so build deployment tools for Wilderness Labs, it's just a case of adding that extension into Visual Studio. The same goes for Visual Studio for Windows as well. So we've got some basic F# application. We're just going to write out hello world to the console. We're going to then create a new application. And then one of the things you have to do is you have to put the this thread to sleep and make sure that it never exits, and that keeps your application running on a separate thread. So if we deploy this application, so the tools, firstly, is going to restart the board and stop mono, so it stops any existing applications that are running on the board. We're then going to deploy the application, and what the system is doing there is it's having a look to find out if there are any files at all missing off the board, and obviously at the moment it thinks the F# core needs updating. It also looks for any file changes, and the idea is that we only deploy any files that have been recently compiled or recently built. The initial setup for the board, it can take about, the first time you deploy an application, it can take about 8 to 10 minutes. And that's because you've got nothing on the board and all of those DLLs have to be deployed to the board, and that's what really takes the time. So if we have a look at the Meadow window, we can see we've got the hello world message. And if I bring in this QuickTime viewer, this is the board that's running live at the moment. So as we can see, the LEDs on this board, on the Meadow board, it's slowly changing colour. And just to show you that the debugging is actually working, we'll just let it step through. Let's just set a breakpoint on the orange colour. And as you can see, that breakpoint's fired. And we can single step over the single step through the code. So that's the basic getting started. So let's have a look now at talking to the light sensor. So in that video, you'll see the Meadow board is here. This sensor at the side of it, this is the light sensor. And the two wires, the red and the blue wires at the back, they're actually connecting the sensor to the Meadow F7 board. So let's have a look at that, how we're developing for that. Talking to the sensor. So let's create a new solution. And this time I'm going to do this in C#. Okay, so this is a little bit structured a little bit differently from F#. We have the main program which creates a Meadow application, which was similar to what was done with the F# example. And again, we put the board to sleep for an infinite time. And the Meadow application itself, we are passing through the F7 micro as our device type, so that allows us to talk to the hardware. And this is the equivalent of the Blinky example that we've just recently seen in F#. So the first thing I'm going to do is I'm going to cut out the Blinky example because we're not going to use that. What we do need is we need the driver for the light sensor that we're going to talk to. So the light sensor that we have is the TSL 2591, I think it is. So if we go to project, manage NuGet references, 2591, and we have the Meadow Foundation light sensor. So let's add that to our project. And there it is. You can see the sensor's been added to the board. So we can now actually start using that light sensor. So Meadow Foundation, sensors, light. So the first thing we need to do is to let's have a look at adding that sensor, creating a sensor object. In the wrong place. And we need a constructor. And inside the constructor, we can create a new instance of the sensor object. But before that, we need to tell the application how it's going to talk to the sensor itself. So we need to do that by something called the I2C bus. And this is just a standard bus for talking to peripherals. So the two main ones that we use on this board are I2C and SPI. And we need, in this particular case, we need to create an I2C bus. Once we've done that, we can create a sensor object and pass through to it the I2C bus. So we've got a sensor object and it now knows how to talk to the actual sensor itself. So the next thing we need to think about is, well, we're going to be getting readings from this sensor. And there's two ways we can do this. We could either poll the sensor over and over again, or we could ask the sensor library to tell us when the sensor's been updated. And that's what we'll do. We'll use old-fashioned events, and we'll create a sensor updated event. And the last thing we need to do with that particular sensor is to start it updating and tell it how frequently we want to be updated. So we'll do that initially. We'll start off, we'll do this every second, so we'll be able to see the readings come through from seconds. We'll do this in a second. Now the next thing we need to do is actually put some code in there for the sensor updated, and I'm just going to copy and paste some code because I think we're looking like I'll be running short on time. So we're just going to take the readings from the sensor, from the result, and we're just going to print those readings out to the console. So let's deploy this application. Let's have a look at the tool output. We're going through the same sequence as we had before. The device has been disabled. We're interrogating the device to find out what files are on the board. And Visual Studio is connected. So if we have a look at the tool output, So there you can see the readings coming through once a second. If I hold my hand over the sensor, you can see the light readings change. So let's have a look to see if we can actually get some data sent out to the cloud. So I prepared a library already for this. If we add, you can see I've called something the Adafruit logger, and this will allow us to talk to Adafruit's data logging system. There's also a secrets file there which contains the keys and passphrases for my network and so on. So let's provide a way to connect to the network. Again, for expediency, I'm copying this code from the sample application. So one of the first things we're going to do is we're going to ask the board to connect to the network. The secrets file, let me just edit that. I think I need to change the namespace. That's what I need to do. I need to change the namespace. So no squigglers, which is good. And the light sensor. Yep. Okay, so we're in the right namespace. So let's modify the sensor updated, and we'll try to send that data out to Adafruit IO. And we need a logger. And let's try deploying that application. Failed. Okay, that's looking good. Okay, so if we have a look at the output, so the board is just restarting. So it's connecting to Wi-Fi. Now this is going to take a small amount of time, but what we can do is we can bring Chrome over, and this is a light feed sensor, a feed on my account that allows me, that is going to be taking the sensor readings and displaying those in graphical format. So we've got a good Wi-Fi connection. Exception. That would help if I created the object. So let's stop that. How are we doing for questions, Steve?
That's it. There's no more.
No more. Okay.
You've got 15 minutes, by the way.
Yeah, that's what I was thinking. So we just need to wait for it to connect to the Wi-Fi. So as we can see, that's the data coming in from the sensor. Just pause that. So they're the sensor readings that are coming through, and you can see the timestamp for the sensor reading. So hopefully there you should have seen that we can talk to a light sensor, we can influence its behavior. You're holding your hand over the sensor, you can see the readings change. We've been able to log on to my local Wi-Fi, and we've been able to send data out to the cloud. So if I take this out of the way, right, what I'm going to hopefully do next is we're going to have a look at a buggy project. And this is on a different board, so I just need to tell the system to connect to this board, which I'll do now. So if we exit Visual Studio, there's a problem with the extension which is being fixed at the moment. It doesn't always scan for the boards correctly. Quit. And if I fire it up again, it should be able to detect the new board that I plugged in. Okay, so this time we're going to use a pre-built project. We've got a buggy. As you can see, it's live. So we have the motor control is down in this section of the board. The range sensor is on the front of the device, and it's connected through to the Meadow through these wires here. We're hopefully going to control the board using the rover using Bluetooth, and this I'm going to use this pre-built project because it looks like we're running low on time. So let's get the system deployed just as we did with all the other projects. What should happen now is the LED on the board should go to permanently on green when the buggy is ready. So it looks like the buggy is ready. So what I'm going to do now is on my phone, I've just brought up a BLE scanning app, and this device is called Mars Rover, which you might be able to see right at the very top. So we've just interrogated the device. We've set on the Bluetooth server, we've set up 4 characteristics. These characteristics control the motion of the wheels. So I'm going to turn the forward characteristic on. Turn the motors on. And the motors aren't working. The demo gods are definitely against me today. So what we should have seen there is the Bluetooth characteristic. When it changed, it would have turned the wheels on to say to move forward. We should have been able to see them change direction. We should be able to make the system go backwards. And hopefully we would have been able to see the light sensor, the distance sensor, being able to detect objects getting closer, further away, and so on. And when something got too close, turning the motors off. But obviously the demo gods aren't with me today, so sorry about that. Let's move back to the slideshow and we'll just finish off. So what does the future hold for Meadow? So we've published a roadmap on the site. We're currently at beta 6. We're looking to get towards a full V10 at the start of next year. V10 will contain over-the-air updates, and we've had we had a demonstration of that at our developer conference, which was held last week. We should have the security stack in place. We should start rolling that out pretty soon. The Meadow drivers that you've seen, we've also started rolling those out on Raspberry Pi and Jetson Nano. So there's a Meadow Linux version of the foundation libraries. That's in beta testing at the moment. We will be going towards, we will be working towards .NET 6, adding ahead of time compilation, so that will convert, will move from interpreted and JIT through to native STM32 code, so that should increase the speed of applications. We'll be adding tree shaking, which effectively we take all of the APIs that aren't used and we remove those before compiling the code. So that should make the application and the libraries a lot smaller on the board, so it should give more space for extra libraries and also for data storage. Power and sleep APIs are coming, as is CAN bus. And one thing we've recently done is we've open sourced the hardware, and we've also open sourced more of the software. And if you want to know more, the links to the roadmap are at the bottom. So hopefully what we've seen today, we've shown you a brand new way of building for IoT devices. You can use full .NET on a board that's got the same processing power as approximately a Pentium from about 20 years ago. You can choose the operating system you want to develop on. You can choose the IDE. We have full debugging support on all systems, and we've got a comprehensive list of libraries available. So Q&A, does anybody have any questions?
No, you answered all the questions now.
Hopefully. Well, if you want any more information, all of this presentation and the code with some supporting links will be available on GitHub. I'll do that straight after this talk, so it should be available sometime within the next hour. The social media links for Wilderness Labs are there are on the left, and my connection details are on the right. If there's nothing else, I'd just like to say thank you very much, folks, and hope you enjoy the rest of the day.